Hi, I'm Swarupa Sail, course instructor for fluid mechanics. In this presentation, we will solve problems on to find whether the flow is continuous or not and how to find the third velocity component, that is maybe along z direction. In this problem, we need to show whether the flow is continuous or not by knowing the velocity components along x direction, that is u equal to 2x, and the velocity component along y direction, that is v equal to minus 2y. And here third velocity component, that is w, is equal to 0. For flow to be continuous, the continuity equation to be used is dou u by dou x plus dou v by dou y equal to 0. Here dou w by dou z is not considered, as the third velocity component w is equal to 0. So we will use continuity equation only for two-dimensional flow. And we need to find out what is dou u by dou x and what is dou v by dou y, and check whether the summation of these two values is equal to 0. If the summation turns out to be equal to 0, then the flow is said to be continuous. To begin with, we will find out what is dou u by dou x. So for that, we have got the value of u equal to dou x. So dou u by dou x is equal to 2 into nx raised to n minus 1. So it will be 2 into 1 into x raised to 1 minus 1. 1 minus 1 is equal to 0. So it will be x raised to 0, and x raised to 0 is 1. So we get dou u by dou x equal to 2. Similarly, we will find out what is dou v by dou y. So for that, we will write equation for v, which is equal to minus 2y, and then we will find what is dou v by dou y. Dou v by dou y will be equal to minus 2 into ny raised to n minus 1. Here n is 1. So 2 into 1 into y raised to 1 minus 1 will be minus 2 into y raised to 0, which is 1. Hence we get dou v by dou y is equal to minus 2. And now we will substitute these values in continuity equation. So dou u by dou x is equal to 2 and dou v by dou y is equal to minus 2. And summation of these two terms is equal to 0. Hence the flow is said to be continuous. And for three-dimensional flow, the continuity equation to be used is dou u by dou x plus dou v by dou y plus dou w by dou z is equal to 0. And this equation has to be used if the velocity components along u, v and w are given in the problem. In this problem, we need to find the velocity component in z direction, and for that, the three-dimensional incompressible flow is having velocity components in x and y direction as u equal to x square plus dou z square plus 8 and v equal to 2y square plus z square minus 6. So since this is three-dimensional flow, we will use continuity equation as dou u by dou x plus dou v by dou y plus dou w by dou z equal to 0. To begin with, we will find out what is dou u by dou x. So for that, we will use equation available for u, which is equal to x square plus 2z square plus 8. Dou u by dou x is equal to nx raised to n minus 1. Here n is 2. So 2 into x raised to 2 minus 1, which will be x raised to 1. So dou u by dou x is equal to 2x. And next we will find out what is dou v by dou y, for which we will use equation for v, which is equal to 2y square plus z square minus 6. So dou v by dou y is equal to 2 into ny raised to n minus 1. So it will be 2 into 2, which will be 4 into y raised to n minus 1, that is 2 minus 1, will be 1. So it is 4 into y. And we will write dou w by dou z as it is. So dou u by dou x is dou x, dou v by dou y is 4y, and dou w by dou z is written as it is, which is equal to 0. Since we need to find out velocity component along z direction, we will take out the term dou w by dou z on left hand side, and on right hand side we will have minus 2x minus 4y. To find w, we will integrate this equation with respect to z. So dw is equal to integration of minus 2x minus 4y into dz. So it will be w equal to minus 2xz minus 4yz plus c. So this is the equation for the velocity component along z direction. Thank you.